Here's prototype Empire. Today I'm going to demonstrate a quick LeetCode drill session with five examples, and the goal is to make this a C++ drill exercise, and I'm going to make it um, a quick drill exercise to demonstrate how to practice sharpen your coding skills. The background is I used to code in Java only, and C#, C++ is I rarely do that, and I want to, but nowadays my working actually requires a lot of C++ coding, so therefore I'm demonstrating how to, practice using LeetCode. I haven't been doing LeetCode for a while recently, so let's get into it. So first of all, I'm going to select a few problem. Let's pick some standard questions. Let's say this is one to some. Okay, actually, let's go with top 75. LeetCode. Let's go with that. Okay. Is not the one that I want. Okay, but yeah, let's go with it. Okay, this is an array problem, binary problem, dynamic programming. This might be too much. I'm gonna start with simple ones just to have some warm up. Okay, this is standard. House robber, twosome, and maximum depth of tree. Okay, I got 5 and more. Maximum subarray. Okay. All right. So we now have 1, 2, 3, 4, 5 problem. Let's get into it. All right. So let's go with C++ for now. Let's go with C++ just to have a quick warm up. So this is twosome problem. Let's reset it. Twosome problems. You want to return the indices, and you want to sum it up to be equal to the target. You want to return the target. So here we want to, as we go through this array, we want to find out 2 numbers that you can sum up to the target value. So every time we visit an item, we want to find it out whether you have seen the remainder. So you want to see x, and you want to find out whether you have seen target minus x. So this is the current value. X is current value, right? So x is current value. Okay, so we basically want to target a one path. So yeah, so we need to save the position of all the previous same values. All right, so as mature as you go through this array. Okay, I have to go through it. Let's see if you have seen the previous values. Map contains key. Then we will return this. And current value, right? That's it. If you have seen it, or you have not seen it, let's add the current values. Okay. And then you move on. In the end, if you don't find it, then you return 0, 0. Okay. Yeah, just quickly do this. Yeah, put the current values in there. So you are iterating through this array, and for every number you're visiting, you look at the current values, and then you save. Yeah, for you check if you have previously seen the remainder before. You have seen sets, then you get a number. You get the positions, and then you store the current value and its positions. Okay, yeah, looks good. Submit it. Yeah, it takes like 5 minutes already. Okay, so now I'm gonna convert this into C++ code. So what I want to do is C++ STL cheat sheet. Let's stay with that. So we need to switch to C++ right now. So in the end, it's gonna be a vector. So in the first one, ordered map, unordered map, right? Let's create this structure. Yeah, that's like a container. So this is a map. Unordered set. Is map ordered or not? I think we should go with unordered map, right? Yeah, unordered map. No particular order, right? So what about this one? What about this map? Is this a tree map? Oh my god. Sorted order. So this is map in C++, tree map in Java. Let's check. Yes. Okay. That's interesting. So now let's get it down. Okay, I'll order the map, and this is type of integer int, right? Map equals uh so we don't actually need to declare it, right? Declaration. Yeah, because we already know how the memory allocation for this data structure it is in the C++. So we don't need to instantiate it. So now let's get it. So going through this vector, yeah, as you can see, I don't know anything about a C++. All right. So which number? Go with that. Which number? Index based. So size t. Okay. Okay. Size, and then let's go through it. So for every number we have visited, okay. So we don't want to recreate this number. We just want to reference its value. We just want to get the address of this number, right? We just want to get this number. And then yeah, get a memory address. Okay. Let's check the number. If map let's find it. Let's find the actual value. Let's get its value. Yeah. Make sure you're not reaching to the end, right? It's not because of that. Okay. Now, if you have not seen it, so let's insert this item in there, insert an element. Let's insert this element in there. So current value, and you're gonna point it to the current position, right? Okay, let's submit it. I actually don't know. I submit this. There must be some issue with it. Let's check the answers to find it out. Guys, what does it mean? Is that unsigned type? Unsigned type. Unsigned type can only store values. Okay. Unsigned type. So what's the error? Okay, let's find a C++ solution. So, it's gonna be two-phase hash problem, one-pass hash problem. So you have an unordered map. It's already defined for each of one of them. Let's find the complement. The complement is this one. So the problem with this solution is I am using it directly. Okay, you're creating a complement. Insert it. Map inserted. So actually you don't need to insert it. Okay, let's simply store it. Then empty. Okay, so this is the solution. Okay. Remember the get. Return it. Okay, it's indexed at this map. Now I can safely use it. So I don't actually understand why you're doing this. So let's check it. Okay, now let's check it. Wasn't sure. What's the time now? I think we are running out of time. Just two problems should be enough. Okay. Yeah, apparently it's so rusted. Apparently the skill set is so rusted. Um, let's clear it out by another question. Just pick another question. That's it. Maximum depth of binary tree. Okay, yeah, that's a good question. Let's go with it. Um, if I go with C++, it's gonna be easy. Let me go with it first. So maximum depth, it's gonna be a recursive. You will leverage your previous solution. So you basically return the max depth from your, first of all, if root equals to null, then we return 0. Next, we're gonna return the maximum depth out of either one from the left or right, plus 1, left or right. If root is now, then we return 0. If root is left side, we plus 1. If it's the right side, we reverse both. Okay, let's find it out. The maximum depth out of the left and the right. So is the timer still on? Let's see. Okay, timer is still on. Let's finish it. Very quick. It's taking too long. So finding out the maximum depth from left or right. So, yeah, for this one, number 3 is gonna go ask left or right. So 9 left or right plus itself. So it's gonna give you 1 from 0 to 1. 20. It may give you a number of, plus myself is gonna be 2 and 3. Yeah, it looks like this is right. Let's go with a C++. Turn max depth. Maximum depth. Okay. Oh, there's only one problem. Okay. Yeah, this is right. Let's go with this. C++. If um, it could be 0, return 0. Math. And double. Let me check. What's the C++ solution? Return max depth, maximum depth, left. Okay. Let's find it out. Plus 1. If root is now is now, say, yeah, if not now, then we return. If now, if it doesn't have anything, then we return 0. Left or right. So maximum depth, maximum depth. Eh, +1. So I think we're down. Um, so both are down, but there's apparently a lot of syntax issues. Yeah, there's a lot of syntax issues. I need to summarize it. So doesn't seem like this is feasible. Okay, so let me end up by asking ChatGPT. Okay, what is a comprehensive cheat sheet for C++ lead coding? Generally for interview. Let's do some summary, and tomorrow we'll do more exercise. So this sheet that turns out not be comprehensive enough. Like in terms of the pointer reference, and also the algorithm, it wasn't very comprehensive. So we need to prepare. So this is about the template. Let's look at the cheat sheet. Let's go with the C++ solution for each. This is loading. Now we're good. So 2 pointers. And wasn't very comprehensive enough. So in the end, I'm gonna create a blob to showcase how this works. So now let's upload this video.